Hello everyone. Let's take a look at our next problem. The system of equations, log of 2000 xy minus log of x times log of y is equal to 4. Log of 2yz minus log y log z equals 1. And log of zx minus log z log x equals 0 has two solutions. x1, y1, z1, and x2, y2, z2. Find y1 plus y2. Interesting. So all the logarithms are base 10. Good thing to get out of the way right away. What am I thinking here? This is just... No, it's not quite a linear system in the logarithms of x, y, and z. Is the best way to do this to simply do some back substitution? You know, use the last equation is the simplest one to work with because the right-hand side is equal to 0. So maybe I solve for log of x in terms of log z. I'm not sure. I'm also not sure exactly why there might end up being two solutions to everything. Is it because I think the way the solutions are going to work is they're going to be reciprocals of each other, right? If I replace x with 1 over x everywhere, oh no, that's not quite going to be it, because some of these factors in here change things. Yeah, I'm not sure exactly where the two solutions are going to come out, but I think there might be some kind of thing going on with reciprocals of the variables x, y, and z. I think what I'm going to start with is take the last equation, solve for log x in terms of log z, and then reduce this down to a system of two equations and two variables and see if there's something simple we can do. Okay, this ended up being a little bit more roundabout than I expected. I think the first thing, something I should have done much earlier, is just replace the logarithms of x, y, and z with other variables, which here I ended up calling capital X, capital Y, capital Z. Just simplifies the notation a whole lot. There may also have been a lot of simplifications that I could have made along the way. A term like this, for example, simplifies a lot. I didn't see that immediately, but this is just equal to, I think this is just equal to the log of 2, base 10 log of 2. And so again, a lot of the arithmetic that I ended up doing would have been a lot simpler if I had done that. So I didn't end up solving for all of x, y, and z. I only ended up solving for y because, of course, in the question, it's asking for the sum of the two values of y. That was pretty easy to manage. Just eliminate all of the variables one at a time, but saving y for last. I ended up solving for both values of y. They end up being 20 and 5. And so the sum of the two numbers that we're looking for is 25. Pretty confident in this. Again, as usual, unless there's an arithmetic mistake, if I find an error, I'll put it in the description, or if I have any other comments to make on this one, I'll put it in the description. Otherwise, thanks for watching.